Hi, I'm Dr. Arthur Bradley, the Director of Research and Development at Faraday Defense Corporation. So today I want to talk to you about some new interface filters that we've developed. So there are 4 different filters. There's a USB-A, a USB-C, both in 3.0, so they have the super speed channels. There's a HDMI filter, and finally there's a LAN filter, which I've mounted to the wall here. Now, these filters are used when you're passing signals in or out of a shielded space, such as a shield room or maybe a tent, a shielded tent. They mount directly to the wall of the panel. There's just some screws that are on the other side that attach it to the wall. They're sealed tightly against the wall using RF gasketing, so there's no energy leakage around the filters. And they provide excellent attenuation of unwanted energy that might get on those cables and pass into the room, or subsequently energy inside the room getting out and radiating away. So what I wanted to talk today about was, first of all, why these filters are important, and then how we validate our filters. So first, if you didn't have filters at all and you just pass signals through the shielded wall, what you'd find is it would greatly compromise the shielding of your space, all right? If you had a 100 dB room, for example, something that had 100 dB of shielding, just passing a single wire through it might drop it to 50 dB. So it can greatly compromise it if you don't have filters on the walls. And you use filters for power signals as well as data filters. These filters are all for data. Power filters are typically much larger, and they're sized according to the amount of current and voltage that's needed. So what you have to do when you develop these filters, though, is you have to make sure that they do 2 things. First, that they continue to maintain the specifications. So for example, if you're doing USB 3.0, you have to make sure that the filter doesn't compromise the signal integrity at those speeds, and that it will perform all of the functions of USB interface. Likewise for HDMI or for LAN. In the case of a LAN filter, you have to make sure that it will still pass power over Ethernet properly. So to do that, you use network testers of different sorts, different type of interface testers. And I just put a couple out here. One of them is a fluke tester that's used for LAN networks, and it just verifies continuity, the speed, power over Ethernet, that kind of thing. And then the other one is an interface tester that's more programmable, where you can do USB-C or HDMI or any of this sort of standard interfaces. It's a modular sort of system that lets you check those. So again, that's the first part, is you check the functionality of the interface to make sure the filter hasn't compromised it. And then second, you want to check the actual filter performance. So if the filter doesn't perform very well, then the filter really doesn't have any benefit to the system. So what I've done is I've set up a network analyzer, which is typically what's used to verify filter performance. And I have connected it up to a LAN board so that the signal comes out one port, goes through the LAN filter and goes back in the other port. And it will then display the filtration across frequency, all right? And depending on how you design the filter, you can get different filtration curves. And these curves generally just tell you how well the filter performs, where the corner frequency is. It will tell you, exactly when it starts to filter. If the corner frequency is too low, you'll start affecting the actual signals of the network signals, and you don't want that. And if it's too far out, you would not filter the things that you needed to filter. Likewise, you want the filter to drop very sharply, which this one does drop very sharply, so that you get rid of the unwanted signals very quickly as you move out in frequency. And then finally, you want to make sure that it drops down low enough that you get enough filtration. In this case, we're showing more than 100 dB of filtration by the time you're at 1 gigahertz, which is quite good. So these are how the filters are tested. Use some kind of an interface tester to first verify functionality, and then use a network analyzer to verify the filter performance. All in all, these filters perform very well and are an excellent addition to Faraday Defense's other products that relate to shield rooms and shielding spaces.